because a lot of the time people would say to me the reason they they're worried about starting things, whether it's learning something new or whether it's like starting a business or whatever. A lot of people are worried about actually like what to do. Like they're worried about failure or worried about not having enough info or knowledge or whatever happens to me to be. And I was like, look, you know what? All you need to do is actually just start. If you're worried about stuff, just start. Yes, I've got more experience doing AI and machine learning than some other people do because my first company did that. But I hopefully want to show you that you don't need to have a crazy amount of knowledge to be able to do stuff like this. And also, learning on stream is fun because I can learn from you guys, but you guys can also learn from me. So the whole idea of this kind of learning stuff is that we all learn together. And the fact that everyone's staying at home is like, you can either follow along with me or you can just watch me or watch a stream later or whatever happens to be. So DeepRacer is essentially an machine learning platform for you to build and train a virtual racing car and then race it around a virtual track. Most of it is virtual. You can actually buy a physical thing, and I'll show you it in a minute. The whole idea is to get so it's built and run by AWS, but the whole idea is to get people into machine learning and stuff. So I think it's gonna be really cool. I heard about it from a friend at Pivot a little while ago, so I was like, let's just get into it. Let's just do it. I'm super into the Grand Prix and Formula One and all that kind of stuff. So I was like, well, DeepRacer seems like the perfect thing because A, I like racing and Grand Prix, and B, with the whole coronavirus thing, there is no Grand Prix happening. So I was like, well, we can have our own Grand Prix online and it should be relatively easy. So to start off with, I'll talk a little bit about like AI and machine learning. So there is a difference between artificial intelligence and machine learning. I'm into F1, woot woot. It is such a rough time being an F1 fan. Hello, hopefully I say your name right, but Sono Fee Evil or Sono for Evil? How do I say this? Can I just call you, or Son, or is it Sono, or Son of Evil? Oh, there we go. Son of Evil. I like when things aren't in capitalized, you try and like split up the word how you know, but okay, Son of Evil. Can I just call you Son? Is that easy? Because I call you Son. So yes, it is a rough time to be an F1 fan. Stacker, so Roshan Stacker is like, yes, we've only met IRL like 4 or 5 times. We have, I'm sorry. It's just your Twitch name. I know, I can see it right now when I look at Son of Evil. I just saw Sono first. I don't know if I saw Sono first, but oh well. We're having fun, right? Oh, that's so funny. Lols. Okay, so back to AI and machine learning. So lots of people say like, artificial intelligence is like one of those buzzwords, and if you have an AI company, then investors will invest in you. So lots of people say they'll have an AI system when they often don't. They might just have a smart system or a learning system. So one of the misconceptions, and even I kind of had this, is that, and a lot of the papers you read online will say that machine learning is a subset of AI, but that's not necessarily correct. So artificial intelligence is a system. Hey Smurf, how are you? So artificial intelligence is a system that prioritizes an outcome over actually just gaining knowledge. So it prioritizes success and it prioritizes making decisions based on knowledge it has. Oh, you went to a research meeting about machine learning to create a brain interface. Wow, so cool. So yeah, AI is an intelligence which will make a decision based on and make the right or the best decision based on information it has. Now, this is where it plays into machine learning because the AI can get the information from a machine learning system that's gathered all the information and fed it in, or the AI can actually get information from people. And this is where we talk about, I was talking about this on stream with one of the other live coders the other day, but Sammy was on stream, I think it was Sammy. It was someone from Live Coders. I'm just trying to think of exactly who it was. But anyway, we were chatting about like the difference between AI and machine learning, right? So the AI will make a intelligent based decision or suggestions based on information it has. So it'll prioritize success, right? And again, it can get that information from a machine learning model, so something that it's there's learnt being fed into the system, or it can get that information direct from people who feed the information in. So that's why machine learning is often considered a subset of AI, because it will often feed the information in. By contrast, machine learning prioritizes the uptake of knowledge and the acquisition of knowledge over success. So it just wants to get as much information as possible and collect all that information rather than actually producing something that is successful. And so I think that's where a lot of people have a lot of misconceptions about what AI and machine learning does. And one of the reasons for that is a lot of the papers that are out there say that, oh, machine learning is the basis of AI, which it can be, but it's not necessarily the case. There's a few other key differences, but the main one being that one system prioritizes success and intelligence and the application of knowledge, whereas the other one prioritizes the acquisition of knowledge rather than the actual application of it. So that's what the difference is. So AI, think of like intelligence or wisdom, and then machine learning, just think of like knowledge collection. So AI is always going to go for the most optimal solution of whatever you've asked it to do, and machine learning will only go for whatever solution it's learnt, whether or not it's optimal or not, if that makes sense. Whereas like an artificial intelligence will also behave in a certain way based on the information that it's been fed. And then ML is very much based on like a learning system. So it's constantly like taking in the knowledge it's got and iterating and learning off that. So for example, if you want to, there's different ways to do machine learning as well. So for example, if you want to train a machine learning model to say, like a computer vision model to say, recognize a cup, what you would do is you would feed in lots of images of cups or glasses. So I'm thinking like let's just say a mug. Mugs are easy. So mug. So you would feed in lots of information or lots of images, on what mugs are, and you'd say to the model, this is a mug, 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 this. So it's constantly seeing lots of images of mugs, and then eventually the system will have enough learning to be able to recognize a new mug. So if you feed it a new picture and you say, what is this? It'll say, yeah, that's a mug. So that's one way of doing it. That's called like repetitive learning. And a lot of that is based on, that style of learning, that repetition learning is what DeepRacer is based on. So DeepRacer is based on repetition. So basically you run your car around a track, and every time it goes around a track, it'll learn a little bit better how to navigate the track, how to do the best turns, how to do, how to basically get better. While true learning is a good game that teaches machine learning, yeah, pretty much, in the applications of it. Sweet! Thank you so much for the follow, Dark Claw 66 or Dark 666 Claw. What is with the evil in my chat today? We've got Son of Evil, we've got Dark 666 Claw. Wow. This is interesting. But welcome to the channel. So yeah, that kind of repetitive learning is what the AI, so the DeepRacer, machine learning DeepRacer is based on. Another key thing about artificial intelligence machine learning right now is that machine learning is being used to actually combat the coronavirus. So one of the things that we're seeing happen right now is testing is a problem, right? Because we need to be able to test people so we know who's got the coronavirus and who doesn't, but that is a very time-consuming process. So one of the companies overseas, I believe it's in China, and they have now implemented this in the China airport. They've trained a a computer vision model to see a mass area of people using infrared cameras and give their temperature or predict their temperature based on the readings of the infrared, and also a few other things that the cloud, also the computer vision sees. And it's able to measure like 200 people in the space of a minute, which is insane. So I don't know if any of you have flown overseas recently, but when I flew through Malaysia back in February, they were screening everyone who came through the airport using an infrared camera. Now that camera, I had to have someone standing behind it manually reading the temperatures that were coming out of it, and saying, okay, that person needs to get tested because they're outputting a temperature that's higher. So using a a machine learning model, it's able to connect all the sensors within the whole airport and then like say, hey, this person in sector 7E needs to be tested because they're outputting a reading that's higher. So there's so many applications of machine learning, and it's interestingly enough being used to combat the coronavirus right now. So I think it's pretty cool. So anyway, let's get into some AWS DeepRacer. So I'm going to start from basically the beginning so that you can all see pretty much how easy it is to do, but also how you would do it if you were just doing it at home, because that's what it's all about. So this is the AI DeepRacer. So again, developed by Amazon Web Services. And it's basically saying developers of all skill levels can get their hands on machine learning through cloud-based 3D racing simulator. So what it's trying to do is give people and developers an overview of AWS and give them an opportunity to use some cloud-based machine learning stuff. So there's a few components to it. One is the simulator, which is where you build your model, and that's what we're going to be doing today. The next one is the car itself. So you can actually get a physical car and then put the simulated stuff that you've done and put it on a physical car and have what you would see virtually in your physical car, which is really cool. And then there's a league as well. So there are both physical and virtual leagues. There's no physical leagues running now for obvious reasons, but you can go to like a physical league and put your little car down that you've trained and then run that around. Otherwise, there's virtual maps and tracks and everything as well, and that's what people are doing a lot more now. So they're saying it's a fun way to learn machine learning, experimenting, growing, and getting in touch with the community. And also there's a competition. So there is actually like a DeepRacer league. So kind of like the Formula 1 where you can like get some really cool prizes and stuff. So if we look at under the hood, I'm just going to show you in a second. But this is it. So this is how we build a model and compete in the league. So you can see here's like the physical track, here's the virtual track, and then there's virtual racing as well. So if you do get into this, it's a really, really fun way to like continue to do stuff and interact with people while working from home, which is cool. So this is under the hood of a car. So these little cars that you can get sent. Unfortunately, they're not available in most places in the world. They're not available in my place, so we can still train the virtual model, which is what we're going to do. But so it's a little 18th scale car, so it'll probably be about kind of like this big, because I've got a 1/10, which is this big, which is like just a normal remote control car. It's not virtual. So an 18th scale is like this little big, so it's small but cool. And you can see it's got a little Atom processor in it, 4 gig of RAM, some storage, so you can obviously put all the models and information you've trained, put it all in the car. It's got a little camera on it. It's running Ubuntu software with Intel. Funnily enough, I'm wearing my Intel Mastery t-shirt today. It's got some batteries and some like ports, USBs and things like that, so you can put it in. So can it run Doom? I'm not actually sure, but we should check it out. So this is what the physical one looks like. So $400, that's $400 US. And there was like a little thing saying, yeah, here we go, this item is not shipped to Australia. But you know, that's, you know, so you can see the size, so it's about that big, you hold it in your hands. But it's really cool, and there's like the DeepRacer loop. It's kind of an interesting looking car when you think about it, but like it's got like a bit of suspension under there, you know, a nice little like aerodynamic kind of design. There's the camera in the back there, or the front, so the front. Yeah, that's the front. Gotta have the camera in the front so you can see where it's going. Yeah, it looks so funny. Like little camera here. So here we go. So this is, you know, a little bit about it. So anyway, so if we want to actually get started, so there's a few things you can do to get started with the virtual stuff. So we want to, so this is to find a race, this is to start racing, but we haven't built our thing yet. So we've got to actually build the actual thing first. Now, when I did it, let's go back to I'm just trying to like remember exactly where I went to get to all this stuff so you can do it too. Alright, so simulator. There we go, build models. Start your journey for free. So run, train, and create a reinforced learning model. So this so that repetitive or recurring or reinforcing learning model is how this car works. So let's start the journey for free. So basically, thanks for signing up to Amazon Web Services. So if you're not already signed up to AWS, you've got to sign up to AWS. I've got to complete my AWS registration. I've already done this. You can see I've got it up here. Mishmanners AWS console. But essentially, once you've done this, you get a bunch of free credits. So it's like unlimited free stuff. So if I do this in an incognito tab, just so you can see what you get if you haven't already signed up. Just do this in incognito. So if you went simulator, get started for free. It'll show you if you haven't signed in. It'll ask you to sign in. And here it'll give you AWS account includes free 12 months. Includes 12 months of free tier access, including use of all these things. So you can sign up as this, so an account owner performs tasks requiring unrestricted access. So it's pretty good. So you get like free AWS. The problem is, well, not the problem, but thing is, you've actually got to put in your credit card details if you want to complete that AWS. But what you can do is go to the actual training side of it. So once you've signed into the console, so AWS signing console, there's a whole bunch of like solutions and things you can do. And what I've done is already gone into this one. So you need to go to AWS training and certification. Let's resume our session. So this is, you've actually got to sign in with Amazon, not with AWS. It even says here, so sign in with Amazon, not AWS. So I'm gonna just go to full screen so you can't see all my crazy passwords and things like that, because you know privacy is key. Password, cool. Keep me signed in. And we'll get rid of that. Sign me in. Welcome back. Cool. Alright, so I did just do this earlier today just to make sure it worked. So it says welcome back. So there's all these different learning libraries under AWS training and certification. So the one you want to go to is AWS DeepRacer, driven by reinforced learning. So it says resume, but I've actually haven't started it yet. So I just made sure it worked before jumping into something. If you don't see a pop-up, cool. Alright, so start your engines. Get yourself revved up, guys. Let's do this. I listen to some music too, so that I can have some fun times as well. Okay, welcome to chapter 1 of this course. Right, so basically introduces your main topics and flows of the course and provide a quick overview of how reinforced learning. Check out the trailer. Alright, let's pause this so we can watch the trailer. Let's see how good this trailer is. Developers, start your engines! Oh wow, they've used like the Grand Prix actual like soundtrack. It's great.
And we're gonna teach you all about it. Hello everyone.
And we're gonna teach you all about it.
I'm here to show you how these 1/18th scale race cars
They look so funny.
autonomous. Participants will learn all about how reinforcement learning drives AWS.
Oh, they're using all the puns. Reinforced learning drives AWS. So that's what we're gonna do. This whole like compete virtually from anywhere around is what everyone needs right now. Everyone is under like lockdown. We need to be able to do things virtually. So this is perfect.
Let's get rolling.
Okay, this video dives a little deeper into the overall topics. Oh, I know. Coveralls though, I know. This is like, here is the Formula One It was actually a pretty nice trailer, wasn't it, Alex? Thanks for dropping in, Alex. Welcome, welcome, welcome. Also, I just realized, only because I saw your Amazon or your like Twitch Prime subscription, I was like, oh yeah, we're essentially using all AWS right now because Twitch is owned by AWS and we're using AWS DeepRacer. I also will say I do work for GitHub, and GitHub supports Amazon as much as it does Azure and Google as well. So we're still very brand agnostic in that sort of sense. All right, so let's start our engines. Let's see how good these trailers keep going, or if they're like, this guy is so funny. I'm Blaine Sundred.
This course is designed to give you hands-on experience with reinforcement learning by helping you build, train, and deploy models in AWS.
Cool, we're deploying models.
Compete in the official AWS DeepRacer League.
Oh yeah.
To that end, we'll talk to you about the physical components and technical specs that make up the device.
So that's the actual physical car, which we don't have, and I'm assuming none of you have either, so.
Reinforcement learning is all about and how it's the engine behind AWS DeepRacer.
So we just spoke a little bit about that already.
To get hands-on and actually start to build and train your own reinforcement learning models.
So this is the part where we really want to focus on the build and train the model.
Then we'll really start to have some fun.
This guy's hilarious. I love it.
Simulated and real AWS DeepRacer environment.
Also, if there's like parts of this video, as in like parts of this, the cars don't ship to Australia. That's what, yeah, I just mentioned that. So this is the car. Oh, we've got a few things. Oh, how many things is opening here? I've got a few things open. What happened to my... Here we go. So if you look at this is the actual car, as King of Engineers said, don't ship to Australia, but it doesn't mean we can't compete in the virtual league because it's all online. The physical car is so you can actually deploy the model that you train and then physically take it to places to race, which we can't do anyway because everything's in lockdown mode. So, yay, fun times. I'll pull up the DeepRacer thing again just so that you can see it. So, there's two components to DeepRacer. One is the model that you train and can race virtually. The other one is deploying that model that you've created virtually onto the physical car so you can race it in person. But still the same thing. So, there's the actual... So if you want to compete here, you need a physical car to compete. But if you want to compete here, you don't need anything except the model that you train. Because the model we train is what we're doing. Alright. Also, if there's any parts of like this whole like loading experience that you really like, totally clip them. I want to see what people enjoy with these. So clip away, post stuff. Well, actually, I can post it for you afterwards. But yeah, I'd love to see what everyone really enjoys with these clips. Autonomous Racing League. Oh yeah.
And it culminates in the Championship Cup at reInvent in Las Vegas.
Which you need a physical event for. So here we go. So here's the two circuits. Hello, Altari. How are you? It's been a while, hasn't it? So this is it, King of Engineers. So there's the two components. So there's the virtual circuit and the physical circuit. Ooh. Okay, that's for 2019. I'm assuming it's like different. Yeah. King of Engineers, I would not be doing this if it was only available on physical cars that we can't get in Australia. Because one of the problems with Australia is we miss out on everything, right? So one of the good things about virtual stuff is we can do everything virtually, and we don't even have to worry about the fact we can't get things shipped here. Altari things are really good, so we're just learning some DeepRacer stuff and seeing how we can have some fun with Grand Prix, because the real Grand Prix isn't happening anymore. So, are you ready? I'm excited. Are you guys excited? Okay, so we've done that. We've talked a little bit about reinforced learning. But let's see what they have to say about it. I want that bomber jacket. Fun. How do we get this bomber jacket? I wonder if I can just like message and be like, yo, we don't get anything in Australia. Send us cool things. Is this guy like French? Or I'm terrible at picking accents, by the way. Learn how to interact end to end. We can't do end to end because we don't have a physical car. Afternoon, Sandman Technical. How are you going? It's been a while. And what's underneath of it? Fully autonomous. Ah, it's too big. Capable of competing in the virtual and physical world. Unless you're from Australia, then you can't compete physically. About as good as can be expected. Yeah, Sandman, I think we're all in the same bucket, which is why we're bringing you as much virtual content as we can, both through my channels. Twitch is also, GitHub is also doing some virtual content as well. Look at how we can bring you more stuff. Most of the conferences like GitHub is involved in, including Microsoft MVP Summit, GitHub Satellite, and a few others have all gone virtual. So we're still bringing you that content to give you some love while everyone's still at home. And then I'm trying to do some of these learning things so that we can all learn together and we can all have some virtual content. So we're all not going absolutely crazy. Right. The reinforced learning is the auto part. And I'm alright. I'm good. Cool. So these are these three types of machine learning. So supervised models are like that. You know, this is right, that's not. This is right, that's not. This is right, that's not. Unsupervised is like it's got to work out what's right and wrong, and then reinforced is like continuously doing it. So Altari's been busy. Oh, you work in healthcare. Oh, bravo to you. You're on the front lines. We thank you so much for all the amazing work you're doing. But yeah, anyone in healthcare sector, you're like our heroes at the moment. I really hope they do some, you know how like after all this giant bushfires, there was that mural that went up outside Melbourne Central saying to the firefighters, welcome to the Superheroes Club. I hope they do something similar for all the healthcare workers because they are all the superheroes at this point in time. So, kudos to you. Alright, here we go. So this is what we talked about a little bit. Training a dog. You give it a treat. Aww, sad puppy, sad face. That is what reinforced learning does. Cool.
For us, that agent is AWS DeepRacer, and the environment within which it's operating is the track. And what is a race car? And a track without a little friendly competition.
Ooh, you're a data scientist? Oh, you're not a medico, but you're a data scientist. Oh, yeah, no, seriously, you guys be working on so much cool stuff. I've seen so many people working on coronavirus cures and helping people who are affected and all that kind of stuff. So literally massive kudos to you.
At the end of this course, we'll talk a little more about the AWS DeepRacer League.
Okay, that's cool. Let's actually watch an unboxing because we don't have a physical car that we can use. So we're going to watch an actual unboxing so we can see what the car is.
I'm Blaine Sundred with AWS Training.
Blaine, oh my gosh, look how different he looks there. Hang on, that was the same guy as up here. Look, it's the same dude.
AWS DeepRacer.
But look how different he looks down here. Well, A, he doesn't have glasses on, but he's got like, he's gone more bald.
AWS DeepRacer. And today we're going to open up our first DeepRacer.
Yay, because we don't have one, so woohoo.
Driven autonomous racing car. It's a 1/18th scale vehicle that you get to load your own machine model into, that you program yourself, and it drives, races, all based on the model you load.
Yeah, there's lots of like projections and stuff happening at the moment based on where we're currently at, where we need to be, flattening the curve, all that kind of stuff. I do very little machine learning for work, just to clarify. I know, right? It's like data science isn't machine learning. I mean, it can use machine learning, but it's not only that. Like, one of my friends is a data scientist as well, and it's like he's very into coding and programming, but he's like, we barely use machine learning. He's like, we use so many other things. Yeah, designing approaches, clinical data, cancer research, all that kind of stuff. Well, thanks so much for dropping in the stream as well. Is this like a break for you, or just taking some time out, or watching while you're at work? I'm actually interested. Yeah, pretty much. Nice. Right, let's watch this unboxing of a car.
Let's take a look at what's inside.
Let's take a look at what's inside. Yeah, working from home since the 12th. I mean, this is the other thing that we have. Might be possible to use the RC car with a Arduino. Well, I mean, the main thing is you need a camera as well. So this is run on computer vision. Oh, Cohen Racing! Thank you so much for the follow. Oh, hang on. I think I got that wrong. Is it Shohan? Shohan Racing? Also, some people are like, oh, you know, we're all in lockdown mode now. It's like, I've been working from home since like middle of February because I work for a global company and we've been on kind of like semi-lockdown since. So it's like, I've been doing this for like 2-3 weeks already, guys. Actually, probably longer now. But yeah, it's like, we'll all be fine. Can you use camera modules on the Arduino? Yes, you can. So you just need to make sure you've got that. Oh, Shohan Racing. Got it. Woohoo. Welcome to the stream. So we're doing an unboxing online because I'm from Australia, and in Australia you can't get the car because this is a physical car here. It's like $400 US, and we literally can't get one in Australia. So we're watching an unboxing of it, and then we're going to do the virtual programming.
This is our Get Started guide.
Oh, she's had to take and leave. Oh no.
On the back,
it's an interesting time. Like, not everyone can work from home. Like, not everyone works in companies where they can work from home. But yeah, it's been a bit hard on a lot of people. Okay, we don't need to know the understanding. Like, show us the car. Yes! Ooh. Ooh, it's got R clips on it. Like the vehicle.
We notice is it's got a plastic wrap on it that's designed to protect the shell. So let's go ahead and remove that before we go any farther.
Farther. Plastic wrap. It's all like AWS branding. So good. Also, it looks way shinier. Yeah, like way less drag. Take that plastic off. The pins! The R clips. We're gonna look deeper inside the DeepRacer. The chassis. I wonder what it's built out of.
Right away inside the AWS DeepRacer is the camera.
Yep. There's that camera.
The car steering itself is based on visual inputs. This is a 4-megapixel camera.
Just like self-driving cars using AI and deep learning to train their models.
Which actually turns out to be better to drive the car. It's got the built-in monster shocks, so it's designed for
there you go.
durability.
It's got the shocks or suspension
components inside, which we'll take a look at in just a bit. Let's finish taking things out of the box though first. One thing you'll
we can go faster than Hamilton. We totally can.
So we go ahead and remove the bottom.
I'm like noticing all these things. I was like, oh, there's like the battery component, there's the arc, oh, there's all the cables.
And power elements.
Who cares about the power and the... Who cares about all these power elements? Just show us the actual car. Okay, cool, yes, we know batteries charge.
The power cable is...
Yep, we know batteries charge. All good.
Nice thing is, the ports we connect them to are very clearly color-coded as well.
Hey, Diana! Faster, faster, faster! Diana, have you been on DeepRacer? I think I might have asked you that. Okay, this is great. So it's basically just showing you how to charge a battery. And showing us all the... Wow, it's like a lot of time just for cables. Here we go, we want the car.
At the vehicle is it will look like your front tires are not aligned properly.
Okay, so this is key for racing. So it's called the oh, you wrote a perfect pass prediction algorithm for the virtual courses. Nice. Okay, so if we build a virtual tow out, there we go. So I was just saying to Diana, so if we build cars like this, then we can actually race against people like Diana. So yeah, so right now, as Sharon Racing said, we've got tow out, which allows it to maneuver easier. If you have tow in, it doesn't turn as well. Tow out allows it to turn a lot easier. Also, this is like a beginner kind of setup too. You mean you don't just rub your feet along the carpet and touch the battery terminals? Lols! So good.
One of your wheels is sticking out to the side. This is intentional. It's part of the design.
Part of the design.
Anchorman's steering, which at
Anchorman's steering. They're not even using actual car terms. Tow out, guys.
As you're making corners.
Oh yeah, we'll have drag reduction system as well on it. You know, we'll be able to activate DRS. It'll be fun.
You actually do not want the wheels to be perfectly aligned.
No, you don't.
Slightly off parallel to each other. It gives them better grip, better traction, better.
It also, you notice, yeah, Anchorman angles. Also, you usually put it on the side where the car is turning more. So that's what he was saying. Basically, it helps with better cornering and things like that. So on my car, hang on, I'm gonna get you my car so I can show you what we mean. Alright, so this is my car. Obviously not a DeepRacer car. So just to show you what they mean. So this is my car. We built it ourselves. It's got lots of grass in it from where I've been running it around. You can see that's the tow out that he was talking about. So, well, what he called it, the Anchorman's angles or whatever the heck he decided to call it. But that's the tow out there. You can also see I've pretty much, these are meant to be like novelty tires like this for more off-road madness. But you can see I've already like pretty much mashed all the front tires, so all the novels are gone. Basically, I now have road tires on my off-road car. Yeah, that Sandman's right. It's set up as for ovals, so Americans only turn left. You can see the tow out on my car, and you do it on both sides and just slightly. You can change this setup yourself, but we've just changed it so it's just a little bit, which helps it corner better. It also helps this. So this is mainly designed for drifting. So we do a lot of drifting and stuff with this car. So it's pretty good. You can see it's got all the very similar components to what this AWS DeepRacer car has. Maybe we can just keep playing this video and then I can show you the components of the car we need more sensors on. Yeah, this thing has no sensors on it. This is just for us to drive. Although, so my neighbors were out the other day and they're like, hey, we've seen your car out in the street. So I was like, yeah. And they're like, how fast does it go? It's like about 120 k's an hour. This car. It's got a pretty awesome battery in it. But you can see a lot of the things are the same. So there's those R clips showing about. Obviously, I've taken the body off, so it does have a shell on top of it, same as like what this guy's got here. It's got a shell, but I've taken that off just so you can see all the components. Yeah, let's see what else he's saying.
You're welcome to look up Ackerman steering if you have questions about that, but it's baked in the car. So if you see they're not aligned, that's a good thing.
That's a good thing. You can obviously change it yourself. I don't know how much you can change this one.
We already talked about the camera. One of the things
so my car has no camera because my car is not a virtual car, and also my car is us driving it. Which is why there's a remote control for this one and not for the DeepRacer.
There are multiple ports to the right and the left of the camera. AWS DeepRacer was built with extensibility in mind.
Extensibility.
It's built to have just a single front lens camera today, but it's got the ports that if you wanted, you could eventually upgrade and have two different cameras for stereoscopic vision. In fact,
different cameras.
Ports that are not in use, designed for future.
That's kind of smart.
Future changes.
So you can add like all different stuff. Add a Jetson Nano. Boom!
That the compute battery will get velcroed into. So once we actually finish charging our battery and hook it up.
So he's got the battery there velcroed in. You can see on most cars what they'll do is so we've got ours here, and it's got basically just a plastic component or plastic kind of shaft that just holds the battery in place. So that's our battery there. Like it takes up a big chunk of the car. So you can see that even though the battery takes up all this or like all this space in the car, which is pretty standard on nearly all RC cars or all scale cars, that the battery takes up so much space. So if he gaffer taped in.
This whole top of the
yeah.
is in fact where the compute happens.
Ooh, all the compute happens there. Interesting.
Two layers, the compute side and the drivetrain. And they're held together by more pins, so let's go ahead and pull these pins out.
So similar to what we've got, yeah, battery is only on one side of our car. So if you see, so on one side we've got the battery component, which is all that bit there. No, it doesn't actually cause uneven weight distribution because you've got the battery on this side, then you've got the motor and control components on this side. So the motor is quite heavy as well. And then you've got the controls and components here. So you've got various different things to control the car. So there's like the drivetrain, so which is that long bit down the middle. You've got the spur in the back here, which we've covered over at the moment. And then you've got the gear, which drives the spur. So you've got each little thing in here does something different. So there's a motor controller and a receiver. So the receiver and the input. So there's a receiver, brushless motors. So on one end you've got the receiver, so that's like the remote control part, and then that sends a signal to the receiver here, and the input here, and then that input tells the motor controller what to do, and the motor controller drives the motor. And there's various different things on the sensor. If I've got, you can see we've got barely any battery left, and that sound you can hear is bad. Basically, when we took it out it was not bad. When we took it out the other day, you can see we've got a fan here. So the fan keeps the motor cool, just like you would in a normal computer. And then the fan has some leaves and stuff stuck in it at the moment. So a lot of the same components that are in this are in the DeepRacer. So the DeepRacer would have a motor in it that drives the car, and then the motor controller will basically be the virtual thing that you program to tell the motor what to do. So with ours, there is no programming on this because we do the controls ourselves by having, essentially a remote control to drive this ourselves. But because there's no remote control on the DeepRacer, its remote control is essentially built into the car. So it has all very much similar components. You got the steering here. As well. Robots don't like drifting. No, this one's so the DeepRacer isn't designed for drifting. This car is designed for drifting. So this is a four-wheel drive car. We could get rid of the human in the loop. No, I don't think Smurf would be happy about that, because the idea of this is that we have a lot of fun. Also, Smurf, who's in the chat somewhere, he is a semi-pro RC car racer, so he used to like race cars and stuff for a living. Well, not quite a living, but semi-pro. You win money from it. It's pretty fun. So this is for us to have some fun. And I like doing this. I like going out and controlling the car and drifting it and having a lot of fun. There is a full-size drift car. Yeah, I don't know which uni that built it, but semi-average. Nah, you're pretty good. But the idea is that we have a lot of fun getting out and driving this and, you know, crashing it occasionally and rolling it occasionally and then building more components onto it. But the reason I want to do the virtual car as well is so that I can use my other side of technical stuff, which is not physical. And also like bring a lot of the stuff that I know from physical cars over to the virtual world. And I think that's, I'm a two-person thing. I love, you know, programming things and getting non-humans in the loop, but I also love having humans in the loop. So for me, I like both. So for me, it's not a question of which one's better. They're both different and they both have different reasons why they're good. So yeah, super fun. But so yeah, a lot of the components are in this real car, or this human-driven car, if you will. Oh, Stanford University built a DeLorean. Oh, I haven't seen this. Oh, Microsoft Air Sim. Let's open this that Dana sent us. Whoa, that's a bit loud. That is very loud. What happened to my... Okay, that's up full. Cool, so this is what Dana sent. So Microsoft Air Sim. I like to start with things. Usually for drones, it now has cars as well. Ooh. Welcome to Air Sim. Is a simulator for drones, cars, and more built on Unreal. Awesome. We also have an experimental Unity release. Open source cross-platform supports hardware and blah, blah, blah. Wow, the experiment, deep learning, computer vision. So yeah, similar kind of thing to what we're doing, just for more. Sure, racing. I like programming cars. Seems like fun. Humans are okay too. I mean, that's the whole idea of doing stuff like this. Again, I like both. So for me, again, it's not a question of which one's better. It's a question of they're both different and I like them for different reasons. Kind of like how I'm super into physical world sports, but I also love digital, like esports and stuff. Diana, she could take or leave the humans, but Smurf and Mish are cool. Yeah, we're cool people. You're so funny, Diana. Alright, let's get back to watching this unboxing.
Now, be careful lifting the top layer off.
This is kind of a good reason why I like stuff like DeepRacer, because it's got both components. It's got physical and digital. And this is why I also love the stuff I do with Rain Scooters, with Smurf and everyone else. So Rain Scooters, if you haven't heard of it. This is why I love doing scooter type stuff and like hardware, because there's both components. There's the physical side of the thing where you build the product and you know, build the really cool piece of technology. And then there's the digital side of it where you program all this cool stuff and components on top of it to do really cool things. This is why I loved Baja Board when I was working with Baja Board. It's why I love the first company I built, the AI company, because we're building both a digital system, the deep learning AI model, and then there was a physical side of it too, where we built the hardware, the cameras and the processors and all that kind of stuff. So, and this is something we talk about a lot at GitHub as well. Something I talk about a lot at GitHub, and even before I joined GitHub, was this whole like melding of areas between software and hardware. And I think for me, this is the area of technology that I love the most, this intersection of hardware and software. Interestingly enough, I actually wrote a contributing piece on this. Engineering Thought Book 4.0 for PhD. So I actually wrote this free ebook, so check this out. This is a free book that's that is out at the moment. I'm gonna just sign up and download it anyway. Submit. So it's all about today's tomorrow's thinking, but today's people. So it's talking about what the future of engineering is like, and my piece or my contributing piece within the article. I hope you make the prime delivery for robots in the future. My piece for this is is about engineering and that crossover between so this is it here. Oh wow, it's in like landscape mode. Cool. So my piece down here, let's go find it, is on that intersection of the digital and the physical. There's different parts to the book. There's a whole bunch of people that have contributed, industry experts, academics, so many different people. And it was initiated by GHD, but GHD aren't the only contributors. There's a bunch of other people in here. So my one is right here. Here we go. So I'll just scroll up a bit so you can see a little bit. So technology is far more than digital, it's physical. I really like this bio that this is the person who did the what do you call it? The person who did the editorial basically wrote the bio for me. It made me sound so like awesome and I feel so humbled by it. But she said, Michelle Manning, tech company founder, hackathon queen, multi-award winning entrepreneur, networked across esports, tech, science, and startup community. So I was like, whoa! Oh, hey, Ladowski, how are you? I'm not too bad. So this is like, yeah, some of the stuff that I talk about. So yeah, I talk about like Industry 4.0 and like how we can move forward in this and how the new age of engineering and technology will include both digital components and physical components. So check it out. You literally just put in your email address to download it. But yeah, it's all there. It's pretty cool and it's available and it's awesome. So yeah, and there's lots of other amazing people in this. So this is Jason. This is my old boss actually, who's awesome. And I like this. We need to amplify the human. There will be no relation nor playing second fiddle to robots or machines and digital other worlds. So she's pretty cool. So she talks about amplifying people. There's people in here that have done virtual reality and drones. Yeah, there's so many cool people. So make sure you check it out. It's pretty awesome. Yay, Ladowski! I haven't seen you for ages. I'm glad you're well too. Alright, let's continue this unboxing.
And you don't want to separate those wires. We can try it from this side, might be a little bit easier to see.
Oh, look at that!
But on the bottom
look.
Here,
Move your hand, mate. Look at that. It looks pretty much the exact same as this car right now when you take off that top component. So you can see here they've got the motor there. They've got the same type of plastic bracket that holds everything in place. Same sort of wires and everything.
That's the heat sink. And when this machine is running, it is running at...
It is running hot.
Processor power. If you just got off a lap around the track, do not touch this. We don't want any burned fingers.
Wow, okay, so the heat sink, so obviously this uses a lot of computational power. Literally the way that we test if our car is overheating or not or needs to have a break, so we just touch the motor. You do like the really quick to see, and if you can't leave your fingers on there for like that long, then your motor is overheating and just needs time to cool down. But these guys got a massive heat sink on this one to keep it cooler.
There's a lot of heat it puts out. So as we look at the side of
I'm melting.
compute, it's got a number of ports just like a desktop because this is a mobile Linux desktop. It's got an HDMI port. You can plug a monitor directly in.
So there you go. It could potentially play Doom for you.
Power adapter port, and then a USB port that we will use to connect our computer with to actually help finish configuring the DeepRacer.
Cool. You can see too, like on the front.
An object.
Okay, cool. We know it's got a computer on it. We know it's got some LEDs on it.
On the drivetrain.
There we go, the drive. So you can see it's got the same, like it's got a bumper on front here. Similar to this, its bumper is a lot further away because it's taking into account that giant camera that's on top, is my guess.
This is the drive motor.
Yep, so that's the same as ours. The motor here.
Please don't touch it. It's going to put out a lot of BTUs.
Don't touch it. That's basically how we test it. Touch it.
The car battery is going to get plugged in.
So it's in the same spot as well.
Plug where we're going to plug
the
that
battery.
in once it's time.
So it looks like the battery sits in the same spot.
The suspension, the wheels, the drive, all happens automatically. Obviously, it's fun to look at. You can see right inside the machine.
It's fun to look at.
The suspension, but nothing else we have to do to set this up.
Unless you actually want to program and change the car setup yourself, which, I mean, most of the programming happens on the computer, but there's probably I reckon there'd be a couple of little tweaks you could make to the physical car to actually make it run better.
Once our batteries are charged, we will move on to the assembly phase. So give us a couple minutes and we'll be right back. Okay,
we don't need to see the assembly phase because we've basically done a similar kind of thing here. So that car is essentially the same setup as this. It has the motor, it has a battery. The battery is a lot smaller, but it's probably much higher power output. Although I don't think the DeepRacers are going 120 k's an hour, which is probably why they don't need a giant battery. And they've got the same thing. They've got a heat sink. So they've got a fan, but then they've got the heat sink underneath. And then essentially all this is the same, and they've just chucked a giant computer on top to actually drive the car with a camera on here. So cool. I'm bringing two of my favorite things together: RC cars and racing. Okay, so we've seen that one. Oh, don't watch it again. Okay, so assembly, we don't really need to see all that. But I would like to see the calibrating. So let's see the calibrating. Because we don't get to do this because we don't have a car. So you put it all together, turn it on.
Minute or so for it to get back to blue. At this point, you should see two blue lights. The
blue
lights
lights.
You've seen before, and now the blue Wi-Fi light, meaning that we've got good connectivity to our local Wi-Fi.
DeepRacer travels at 2.8 kilometers an hour. I love it. So that's why the battery is not that big, even though it's got a power computer. You can see the real estate that our battery takes up. It's huge. So that's our battery. It takes up like a giant amount of real estate. And this one, we've got two batteries for the car. One battery has higher torque but lower top speed, and the other battery has lower torque, higher top speed. So basically it's that, as Sandman's saying, the DeepRacer is on par with iPhone battery, but this goes like 120 k's an hour as opposed to 3. So I was like, why is the battery so small? Like, how fast does DeepRacer go? Okay, so it goes a lot slower.
Assembly, put the shell back on.
Plonk. Okay, we don't need to watch you put R clips in.
Next, calibration.
Okay, this is the part we want to see because we don't get to do this part because we don't have the actual thing.
The IP address of your DeepRacer.
Ours has lithium-ion battery.
You probably need to be on the same Wi-Fi router as
there are a lot of cars like ours that you can get that are either nitro powered or petrol powered. Electric power is the best one though. How are you meant to drift at that speed? Really easily, actually. The higher the top speed, I mean, obviously we're going 120 k's an hour in a straight line, but the drifting is great. Few reasons you can drift on this is A, it's off-road, so we find like gravel or like really loose surfaces. She'll find a way to drift at any speed. Also, this car is four-wheel drive. So it's actually a lot easier to drift when you've got four-wheel drive. So lick the stamp and send it. Oh, how you entered the DeepRacer at 2 kilometers an hour. Again, Sandman said I'll find a way to Ludovsky said I'll find a way to drift at any speed. That is my goal. How are we gonna drift at 3 k's an hour? This is gonna be fun.
DeepRacer, in order to connect to it, I've already connected to
lick
mine,
the stamp and send
it is time to calibrate. So on the left-hand side, select calibration.
We're still in the setup phase. Wow.
The first thing it asks you to do is to set the vehicle on the ground. Now for me,
okay. So what we do when we calibrate was we basically test it. So we'll drive it around in a circle. Okay, it's not quite finished. Let's calibrate it a little bit more to the right or left. Let's put the toe in or out a little bit more. So that's how you physically calibrate a car. This is doing it digitally. And what he's done here is he's put the thing on put the car like on a block or a mount. Basically, whenever you store the car, even if you've got the DeepRacer, if you've got any kind of car like this, you want to store it like on a block. So you put something here so the wheels aren't, so it's not sitting on the wheels. The reason for that is you don't want to stress the suspension when it's not running. So you store it on a block so the tires are like free. The reason he's doing it now is because he's going to spin it up and drive it while it's on a block, and you can either do it just while it's in your hand or putting it on blocks really easy as well. If you sand the tires down his W40, anything will drift.
A roll of tape that comes with the car and balance the car on top of that. All
Or just
four
hold it.
wheels are free to turn. They can steer right and left. That way we can see how fast they go, make sure they're calibrated. I'm all set. Click next. So now we want to calibrate the steering angle.
Okay, cool. So this is just doing it all digitally.
And want to slider here, and as we turn it more towards -10, the wheels are turning more to the right.
Okay, so he is basically again digitally calibrating the toe on the cars. On a physical car, you do this by changing how much this is screwed in. So this is the what we just call the dog bone here, and then you can also change it by moving suspension as well. So you can see right now we've got the suspension set on the middle top bracket or in the tower. You can change it in or out. So the lower suspension, the lower the car will be. The higher the suspension, the higher the car will be. It'll be harder to control. We usually just put it in the middle because it's just the simplest and easiest to do. So this is cool, like learning the difference between digital calibration and original. Hey Ford, how are you?
It says the left wheel front, left wheel back are aligned. Now the nice thing is when you're done with all this calibration, if you come back next week, next month, you can always recalibrate your car.
Yeah, recalibrate the car.
Next step.
So we calibrate by driving. So we just go out and drive it. It's like, no, it's a bit too much one way.
What the maximum left is.
Oh, this is interesting. Okay, cool. So the other way to calibrate a physical car, so what we'll do, so he's trying to work out the maximum left and right of the car. So what we'll do is we'll get the controller out and we'll turn the wheels all the way to the left on the controller, and then set, so we'll like basically like turn the wheels so they're all the way to the left like that. And then we'll set the controller, like the radio controller, is that's the limit. Because one of the problems people have is they don't set their controller up properly, so they'll turn all the way to the left and the car will be at maximum left, but then the controller keeps turning. Or vice versa, is you turn the controller all the way to the left, but that's not as far as the actual car goes. So it's really important to set this up properly so you can actually turn the car left and right using the controller. So he's doing this by digital calibration right now, which is you set the maximum and minimum point. So the minimum point is when it's straight like that, and the maximum point is when it's turned all the way to the left. So that's important for driving, because if it's...
The wheels can turn, even though you could try to turn the steering wheel past that point.
So that's what he's talking about.
Case, all the way at 30 degrees left, I can hear that the servos are kind of maxed out. So let's go ahead and back it down a bit. So as we turn it down and bring it forward, eventually the wheels start turning towards the right.
And then that's where you know the point of changes. And if you don't set this up properly, it means that your DeepRacer, once you actually program it, it's not gonna line up with the code that you've or the model that you've trained it on.
That seems to be about it.
So that's all he's doing. He's just calibrating all those bits, calibrating the speed. Let's have a look at the speed.
My element here, my wheels are actually turning backwards. 0 is not 0 for me.
What's the thing?
So if I
That's the thing. AWS DeepRacer. Yep, that's what we're doing today.
I can hear a little bit of a whine, and the whine goes away at -6. This to me is a neutral charge. Nothing's moving forward, very oriented properly, and that forward is forward. but that's getting into the turbo range and possibly the dangerous range.
The dangerous range. Oh, turbo range. That's what we want.
Good fast speed. So for me, I'm going to go ahead and set it
Whoa!
at 27 or so.
No, no, put it all the way to the end.
Forward. Next step, backwards.
Wait, tried accessing. Hang on. You should be able to access AWS DeepRacer. So, hang on. This is it here. So, DeepRacer is there, and then you should be able to go, this is the training session, so go to AWS training. And if you can't find it, just search for, I wonder if I can just do a Google search. AWS training DeepRacer and see what comes up. There you go. Actually, here we go. Getting started. Unboxing, assembling, calibrating. Build your model. Here we go. There is the link. Direct link. Hey Adam, how are you? Good to hear you and see from you. There you go. So that's a direct link to the learning. So all you need to do is sign in. Note for this, the AWS training certification, you need to sign in with your Amazon account, not your AWS account. What's going on? We're learning some DeepRacer stuff, which is fun. Alright, so he's calibrating the car. Cool. He's calibrated all the speed. Sweet, and this is how they do an actual lap around the track. Oh, there we go. Your company has AWS account, doesn't have permission to access it. No, just set up your own account. So when you go into it, you can set up your own AWS account and it'll give you 12 months of free credits. So you should be right. Oh, drats. So there you go. It's going around. Lastly, you should encircle all points on the track with a barrier between the sideline and track. So there's the contrast. You can see it's very green, very black, and very white. There's not much change between the terrain, so you can tell exactly what the road is and what's not road. Cool. Get hands on and evaluate your first model. Okay. Around the track. Oh, Michelle! Michelle's in this. I'm in this. Yeah, not even hitting the apex. So Diana's talking about the apex of the car, of the track. So if you know anything about racing or Grand Prix, you know there's basically a desired, Shohan racing. You'll know there's a desired line to actually drive the car. So I'll show you what it looks like. Apex, desire line Grand Prix. So basically, not desire line, racing line. It's called the racing line. So let's see if we can, somebody's got an image, or just give me a track and I can draw it. Track. Grand Prix track, top down. Pro drivers stay in the middle of the track so no one can pass them. Lols. Alright, cool. That's give me a track. They're all really low quality. They're only bad drivers. Lol. Okay, let's just pick up this one. Save image as. I'll just save it under downloads. And then we will open it in Paint. Wow, it's tiny. Okay. No, we don't want to edit it. We'll just draw on top of it. Draw. Okay, so basically, if F129 should show something. Yeah, it's annoying. Okay, so, oh, there we go. Cool, we got drawing. Let's make it, red so everyone can see it. How do I go backwards? Okay, let's just do this part. Okay, so basically, when you drive around a track, like when you normally drive a car, you would drive like kind of like this. You would come around the corner. You kind of do this, and you just kind of like follow the road. If you're like normally driving a car, but in racing, you actually want to follow the fastest racing line. Now, the fastest racing line is keeping. Google Racing Lines Explained gets me the images I want. Google Racing Lines Explained. But I'll finish off this. So basically, what you want to do is hit the fastest line for racing. That usually means keeping the car as straight as possible so you can brake into the corners and accelerate out of them. So an apex for here is like you come wide here and then you hit this part here and there. Now this is called the apex. So you can see you're coming really wide here and then you're cutting off the corner there. Now you would never do that when you're actually driving a car because there's lines on the road. You got to stay to your side of the car. But that's what they call the apex. So again, here it'd be like that. You're coming wide around there and then hitting off that corner. That means you can come straight into, come into the straight at the fastest speed possible. So if we look at what Sandman said, so Racing Lines Explained, should show it better than I can actually like draw it on the thing. It's a bit hard. Here you go. So this is one kind of image. Here we go. This one. So you can see that like this is the best line. So green is the proper line. So this is that coming really wide and then cutting off that corner so you can hit full throttle and like really straighten up into the what they call like the straight or straighten into the straight. It's pretty easy. So you can see if you miss the apex, so if you turn too late, you'll hit the apex there and then you'll be like outside the racing line. You'll actually be off the track. So what some drivers do is they hit the apex a little too early, not super early, but a little too early, and they'll hit it here, which means at full throttle, they're doing it here, and they're actually not straightening into, they can't actually straighten into the straight. Oh, it sounds really annoying. They can't straighten up the car into the straight until later, which means your lap time is a lot slower. So the second video on the search page is way better. Let's have a look at that. This one, discussion of the racing line. It's really hard for me to show it. So basically, when you're coding your car, you want the car to be able to hit the apex as much as possible because it means that the line that you race on is so much faster than anything else. Yeah, well, my search page is using Bing at the moment. This one, hitting the apex.
Hello everyone and welcome. In this video we're going to be determining the location of a corner using two circles. Turn down the radius as possible without worrying.
Okay, so that's what you would normally do on the road is like follow the normal line of that red line is you just like follow the road around. But when you're racing, you want to go fast. So you come wide and then you cut off this corner here and then straighten and accelerate into the straight.
Grip. Using the example with the 20-meter radius and the 40-meter outside smaller path, the red
there you
line.
go. So there's a racing line.
To have a 1,000-kilogram car with tires which have a frictional coefficient of 1.
Yeah, way so. So that's the apex there. So that's what they call hitting the apex. You can see they're using the radius of a circle because the wider the radius of the circle, the faster you can go around that circle. The tighter the circle, the slower you have to go to actually make that circle. So you want the circle to be as wide as possible when you hit it. So that's what, if we go back to, smooth is fast. So if we go back to here, you can see basically this car was not hitting the apex. The apex here would be, I mean, they're pretty wide circles anyway, but the apex would be coming around here and then chopping off the corner there. And that's what we're hopefully gonna, program. And yeah, we basically want to minimize the turning angle because the sharper the turning angle, the slower you have to go. Whereas if the arc is nice and wide and smooth, you can go a lot faster. So that's what we're doing. All right, let's go test drive in this car with me. Yay! This is not actually me, just FYI. I love it. It's like, so that's when it starts off. So.
You got this one. Here it goes. Stay on. No, stay on. Okay, we got this in. There it is. Nice. Nice. Time. 67 seconds.
Woo!
Good. That's a good first time around.
Thank you. So what was your first time around?
68. So better than mine. Now my current
Okay.
41 seconds.
No way.
41's my current time.
That's awesome.
Developers, I'm here with
Okay, so these basically cut 20 seconds off by
Michelle,
repetitive
and
learning.
We're having fun getting our fingers dirty on the track.
Yeah.
So as we talk about differences in time, the way you get there is one of the cool things about DeepRacer and reinforcement learning itself. It's being able to look at all the options and the parameters and the hyperparameters. And each one of those are knobs you can turn and tweak. And sometimes you get a little improvement. Sometimes you'll see a really big improvement.
And this is exactly what happens in real racing. So if you've ever watched F1 testing, what they'll do is like they'll go for a drive. So you'll see Daniel Ricciardo is the best at it because he gives really good feedback when he drives. So you'll see they'll have like the wind shafts on the car to like detect how much airspeed is going and where the airflow is going, detect any drag. And then the drivers will come in and go, yeah, so it's good, but it needs a little more turning to the right when I hit a corner. Or we're getting a little bit of drag at this speed or that speed. And so every lap that you do, you're making tiny little tweaks. It's currently on the family farm. Aw, go Danny. Good on you, Ricardo. But this is what they do in real F1. It's literally just as many laps as possible. And they'll do it virtually as well. Like they'll put the car through like a wind tunnel and take out as many readings, make small adjustments. The exact same thing we're doing in DeepRacer. So every lap you do, you'll make small adjustments and you'll tell the car to output that and do that.
Sometimes you'll just experiment and it might work and it might not, but you'll learn from that as well.
So there we go. We'll learn from it.
It's the first time I've ever touched something like this, and it's amazing to get it to actually work.
Well, you know, and that's
There you go. First time she's done it, and you can actually do it. So anyone can do it.
I have to ask, if I keep tweaking this, I keep playing, am I going to be able to get to 41 seconds?
Well, the truth is, you'll probably do better than me. There's a lot of people right now on the leaderboard that have times better than mine.
Wow.
So with that, we're going to go ahead and go back into the simulator and learn how to tune your models, and eventually get right back on the track.
Sweet. Cool. So here's how the workflow works. So we create a model, then you configure it, train it, evaluate it, clone the model. So as you can see, this is a loop, and it's a loop for a reason. So you can reward fun functions and hyperparameters. If you can't see that, let me know. I've got my computer on dark mode, which means these things are coming up dark. So the first thing you do is create the model. And then you input. So you never go back and create the model again. But what you do is you clone the model, evaluate it, reconfigure it, retrain it, reevaluate it, reclone it, reconfigure it. And this is a continuous loop. You can deploy it to the car and then keep this loop going and then deploy again later. We're going to stick to this part because we don't have an actual car to deploy to. But this is the part that we want to do. So we create the model on the console, and then we use that console to configure it. And then the simulator is used to train and evaluate the model. So that's what we're going to do, is we want to go for that simulator. So yeah, we're just like continuously doing it, and you can see it in real time, which is great. We can evaluate its performance, yield percentage, overall time it took. You can clone it and start to tweak. And that's what we want to do. Once you have a model for it, you can deploy it to your car and get racing on the physical or compete your model with a virtual track. So we should be able to deploy the model virtually and race it on virtual tracks. Because it says here, deploy it to the car and get racing, or compete with your model via virtual tracks. Cool, so accessing the console and building your first model. Let's check this out.
Welcome back. Now that you've seen the car,
We've seen the car.
Reinforcement learning is driving it, and watched me and Michelle race around the track,
Oh, yes.
you're probably ready to get started.
Yes, we've been ready to get started for a while. Go.
You have to take a few small steps first. This section will walk you through a demo of building your first model.
This is what we want to do.
Default options the service console provides. No tweaks or any fancy customization just yet.
Just yet.
Join me while I walk you through this process in the AWS DeepRacer console.
AWS DeepRacer console.
First, navigate to the console.
Okay, so let's go here. So first of all, we need to go, so there's 4 exercises I'm doing. The first, blah, 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 access the instructions, download and unzip this course package. Cool. Let's, whoops, don't open Photoshop. Just put it under downloads for the moment. Resource pack. Whoops. I just want to unzip it. Okay. Cool. So, number 1. Model using the AWS DeepRacer console. Sorry, I accidentally opened Photoshop in the background. Okay, so by the end of this, we'll be able to access and navigate the console, identify the steps that we go into building a model, use a basic rewards function to reward our car, like you said with the dog. Experience using AWS technologies, a basic understanding of machine learning models, partially reinforced learning, and how it applies to DeepRacer. Meh. Move on. Okay, in your AWS account, go to the management console. Cool. Dana, if we get stuck, I'm so asking you for help. I'll make this a little bit smaller so you can kind of see both things. Oh, look at that. Oh, it's giving me an Xbox Game Pass background. That's so weird. Okay. AWS account. Cool. I do not have the AWS command line installed yet. No. My account. AWS Management Console. Okay, so to do this, because this looks like it's region locked, as Ford has said, we need to set the region to US. So it's saying over here, choose US region in the top right. So we're going to go up to top right. Top right. Ohio. US 1. So this is the region we need to choose. So cool. Thanks, Dana. Then the top left, click services. And then we type in DeepRacer. Fully autonomous 1/18 scale car. Okay. Oh, thank you for your services. May take up to 24 hours to fully activate. Click services, click DeepRacer in the checkbox, open the model. Okay, complete setup. Alright, I'm just going to make sure this is... Alright, I'm just going to turn off while I make sure any information goes in. So, key thing is, I thought I did this last night, but obviously it didn't work yet. Make sure you set up your account and get it verified. Verify and add. Okay, so you got to add a credit card, but you won't get charged for it. Do keep an eye on it though, because I know people who have like accidentally used up all their free credits and then accidentally been charged like a ton of money. So keep an eye on what you're doing and how much time you're spending on it. But we should get 12 months of free stuff. Okay, so sending a verification code. Okay, let's see, continue. Okay, so if we go back to here, so you can select different things. So we want to select our free account. So you still have to put in a credit card number, even for the free account, but you basically just get free. So included in all accounts. Sweet, thank you for using AWS subscription. you'll now be up to date with all services. So we go back to the management console. Find DeepRacer. There we go, DeepRacer. Open it up. Okay, so it says it might take up to 24 hours. No, just let me go into it. Alright, so I reckon... No! Well, you know what? We have been going for nearly 2 hours anyway. At least an hour and a half, so... Oh, wait. Let me get you on what? I was going to say, at least I have content for my Friday learning session if we can't get up morning. Hang on. Dana's get you and... Oh, okay. Alright. Diana coming in with the goods as always. You're amazing, Diana. Diana has got me a user. So we can do it. Does that mean I'll have to do it again on my own account? Because even if we do, we can like do a little bit. Spin up a massive VM. Lols. Otherwise, we can just, it's only going to take 24 hours. And the idea is that we're going to do these learning types of things 2 days a week. So Monday and Friday. So I could leave this till Friday. Because we actually have done a fair bit. Like we've talked about what AI is, what machine learning is, what the DeepRacer model is built on. We've showed you how to do a car, but no, we want it today. Oh, lols. But then what am I going to do Friday? I have to think of something else to do Friday. In my DMs. In my DMs. All my DMs. Alright. Alright, I'm just going to turn it off the page so you don't all see what I'm doing. Thank you, Diana. Hey, I just created a console anyway, so why not? Let's just use this one. Yay! Cool. Mish manners. Sign in. Oh, cool. I love it. Using Diana's account ID. Thank you, Diana. Sign in. Old password, new password, retype password. Okay, I'm going to create a password for this so we don't forget it. Username, password. So I'm just doing this. Dana, you're amazing. Confirm password. Sweetums as team. Cool. Alright. We are back in business. Okay, same thing. Go to AWS. DeepRacer. Bring. Friday's virtual drink stream. Walls. Love it. Okay. Yay. We have DeepRacer. Awesome. The fastest way to get rolling with machine learning. I love all the puns they're using. Like, drive your artificial intelligence. Like, the fastest way to get rolling. Lols. Alright, so we add that on the landing page. Click create model. I'm guessing just this gets started. Optional. So we've done that one. We want to create the model. Oh, we got to create the resources for this. Cool. We've got to create resources, so make sure you've created all the resources. Much adrenaline. Cool. ADO needs an account resource so you can train and evaluate the models you build. Alright, looks like can't find valid IMA roles. Sad face. There is an issue in creating a resources stack. Yeah. Probably it can't have more than one because I'm assuming you're doing DeepRacer already. So it might not allow you to like do more things. So I reckon we leave the next, not on that account. Yeah. I reckon we leave the next step till Friday because then it's like build, like we've done all the initial stuff and then Friday we can build and train the model. Like I think it'd be a great idea. I'm also getting really hungry. Is anyone else hungry? Try again. Okay, refresh. You have valid roles. Eat, Mish, eat. I know, I do have to eat at some point in time. Eating is good. Also, I don't know if you guys saw, but I just got accepted. You can see up in the top corner there, all my stream teams are like cycling over. So I just got accepted into the Live Coders stream team. They sent out a thing and was like, we would love to have you. And I was like, oh, you guys are so good. So this is why we're doing, well, not the only reason, like we're doing learning modules for various reasons. One, everyone is stuck at home. 2, I want to learn more stuff. 3, I like learning with a cool community. And 4, it creates like awesome funness for everyone else. So I think it's a really, really good time. I'm just going to let that, it's still loading. It might not actually load, but we'll see how it goes. But so there you go, the Live Coder stream. So massive shout out to C# Fritz, who you've seen in my channel, and to everyone else. So we're going to be doing some really cool stuff. Can teach an AI over to cook for me, Sean Racy. But also it's good to listen during the day while I work. And that's the other thing. I wanted to create something fun for everyone just to listen into while they're at home working. So even if they're not like super interested, it's different content. It's something that everyone can like get behind. And then it's something that we can all kind of do together. And I think it's really important too that we all have this like kind of social connection while we're all being socially isolated. So yes, thank you so much to Live Coders and the team. And there's some really cool stuff that's actually happening soon. So heaps of hackathons are happening around coronavirus and coding. So I'll be hosting another virtual hackathon go live session on the coronavirus. So there's one that's just started now and there's a new one coming up. So if you want to see, make sure you're following along. I know nearly everyone here is following the channel, but there'll be some notifications on my socials. So follow me on any of the socials for the next virtual stay home hackathon that I host on my channel. Also tomorrow night's AMA session, so Ask Mish Anything session, which have been going really, really well. Tomorrow night's session will be all about hackathons. Well, hot topic is hackathons. You can obviously ask me anything. We'll be talking about well, it was really loud. We'll be talking about hackathons, what they are, how to get started, how hackathons are really good in this virtual age, and also a few of the hackathons that are happening at the moment. We've got the GitHub hackathon, there's a few other virtual hackathons, there's some coronavirus hackathons happening. So we really want to give everyone some tools and knowledge on what hackathons are happening and what they are and how you can get involved and how you can stay sane while staying at home and also stay connected while being at home. So next AMA session will be that. Let me check my email really quickly to see if they have actually said, yay, we want this stuff. So basically there's 2 main hackathons that are happening focused on our kind of time. So one's a stay home hackathon, one is the coronavirus hackathon. So there'll be more info on that tomorrow night on my AMA sesh, which will be great. Well, hang on. Ooh, okay. So I reckon Friday we continue this learning. I think it'd be really good. Also, it's kind of like a part 2. Yeah, so we can actually program the DeepRacer. So yeah, I think it'll be fun. I hope you've all enjoyed. Yay for part 2. Yeah, also because we're trying to keep these streams to like 2 hours, the learning streams. A, because there's only so much learning everyone can take in one go, and B, I'm still doing this during work, so we wanted to make sure that people could tune in for small chunks and not have to worry about taking heaps of time out of their day, but also have something just to tune into. So yay for part 2. Maybe we can do part 2 and then race it against your model, Diana. I'll probably do terribly, but maybe there's something we can do there. But I think this has been a good like start to this. Also, I just want to show people how easy it is to start. So obviously it's taken us about an hour and a half, 2 hours to get started, but we've stopped a lot, we've talked a lot, we've watched all the videos. Like it does say that we can essentially create a model and race it in approximately an hour. So I think that'll be good for the next streams. That'll be like our 2-hour thing. And we did spend a lot of time explaining like what has happened with the physical world and how that's being translated to the digital world with the virtual races. So I think that's really important to note, is that whole what can be translated from the digital, from the physical to the digital. And this is something that comes back to what I've been talking about in our AMA sessions and online, in the sense that this whole stay-at-home thing doesn't mean you stay completely socially isolated from people. Work from home doesn't mean we all just go home and work in our own little bubbles. It means that we all still do what we were doing normally. We just move it to virtual as much as possible. So drinks on a Friday night with your team, do it virtually. Morning coffee sessions, do them virtually. Still have your one-on-ones, your stand-up meetings, your team meetings, your sync meetings, your project meetings. Still do all those kind of things, because A, you need to stay on track with work, but B, and more importantly, we need to stay connected with everyone. And people could very easily go insane by not seeing people during this kind of day and age. But the fact that we have all these resources at our disposal, like we're able to get on Zoom calls, Skype calls, Google Hangouts, and those kind of things, it's so important to maintain those connections with people. Like, I've said this a few times, but imagine if this kind of thing happened like even 10 years ago. We would be like in a pile of mush, because all these services and internet just didn't really exist like it does now. So in a sense, we're very lucky that this has happened at a time when we're so digitally connected and we have all these resources available and at our disposal, so that we can do these types of things. So saying all that, we will be back on Friday to do more DeepRacer and actually program the model, because I think it's going to be really, really cool. But for now, time for me to have lunch, even though it's like 4 o'clock. Oopsie. I will be back streaming tonight. I haven't thought of which game we're going to play tonight, but if you have suggestions, because you are all here right now, I'm going to give you dibs on first game. So if there's a game you particularly want to play. Ooh, Dana wants me to play Fortnite. What do we think, guys? Should we play Fortnite on Tuesday? I know Fortnite is exclusively saved to Friday, so Friday will always be Fortnite. It doesn't mean that it is only on Friday. It just means that Fridays is always Fortnite. So we could do some Fortnite on Tuesday. We could also do some Shadowverse, some Dota, some Runeterra, some Overwatch, even though Overwatch has been really bad at the moment. We played some Final Fantasy 15 last night, which was really fun. So there's a whole bunch of different types of games we could play. so there's lots of things that we could do. I'm pretty happy to play some Fortnite, Diana, if you're keen on getting in on the act, because I know that you want to play some more Fortnite and do some fun things, but I will also do whatever. There's league, so basically my schedule for this week, so tomorrow night's AMA session, then Thursday night choose a game, or I'll choose a game, it'll be fun, and then Friday during the day we'll do DeepRacer Part 2, so make sure you tune in, and then Friday night will be Fortnite, Saturday night will probably be Shadowverse, Sunday night is RPG night, then Monday night it's back to whatever kind of game we feel like it, whether it's League or Overwatch or whatever. So yay, Diana's keen. We'll let you know, keep an eye out on the stream notifications, keep an eye on socials, we'll have some fun. But for now, let's go raid another one of the live coders and say thank you again for welcoming me to the team and chat to all them. So we've got a couple of people online. We've got Talk to Me Gooseman, who is doing serverless functions and Twitch APIs, which looks really exciting. So I reckon let's go raid Talk to Me Gooseman, because he sounds like lots of fun. Alright, so everyone go be nice, be awesome, say hi, and catch you all Friday, probably roughly the same time, about 2 o'clock. Let me just check my schedule and then I'll give you a time now. Yeah, 2 o'clock on Friday will be DeepRacer Part 2, so make sure you tune in, it's going to be really fun. Looking forward to it. Catch you all then. Let's go raid this Gooseman, and I'll see some of you back here tonight for some more fun times gaming. So let's go. Thank you again to all the new followers, all the new people, all the new likes and drops in and chats. We had a great time today. I'm really looking forward to the next one. Alright, catch you all then. Bye!